Hello, everybody. Welcome back to the next talk that we have today. The speakers that we are going to have is Florian Rappl, which is going to talk about something which is I'm very interested to hear about, which is how to create microfrontends with Blazor. So without any further notice, Florian, the stage is yours and your own.
Thanks, Jill. Awesome. So let's just dive right into the topic. I have some Lego bricks with me. So this is what microfrontends are about. They're about being able to compose on the fly what you actually envision. Just a little bit of background on my person. So my name is Florian Rappl. I'm from Munich in Germany. I'm a solution architect here at a company called Smartport. We are specialized in IoT and embedded computing, doing a lot of digital transformation projects lately, especially in the area of distributed web applications, which is also where microfrontends really play a crucial role. Besides my work as a professional, my day job, I'm also an open source enthusiast. I'm a Microsoft MVP for development tools now almost, I think, 10 years. I do a lot of projects in the .NET and JavaScript, I mean, mostly TypeScript here space. And I do write some articles for various blogs and magazines. Currently, I'm also writing a book on this topic of microfrontends. It will be released next year in June. I'm quite excited about the topic in general. You can find me on Twitter. My handle is Florian Rappl. And now let's just dive into with a motivational example. These days, the, let's say, state-of-the-art system architecture is, you guess it, microservices. It doesn't mean that it's the only choice, but it's a very popular choice these days. And of course, there are some reasons. Let's have a look at the, let's say, sketch that I brought here. There are some services, A, B, C, that may be exposed to the outside world. And maybe we also have some helper services like X and Y in this case. So what does this architecture now bring us? One of the great benefits of using microservices is that we can scope around the business capabilities, which means you can always say, oh, I got something new, a new feature, let's make a new service for that. I have an existing service, oh, now we changed a little bit. Well, it's very well bounded where the change will happen, right? And that's a great advantage, especially when you can now distribute the work among really autonomous teams. So they can work independently, they can ship the code, they can make the changes, maybe they have dedicated product owners. It's really about the teams here. That also comes, of course, with some constraints. If you have a very strong coupling, then you usually lose the scalability approach and the bureaucratic apparatus that's needed is much higher. Therefore, you should always try to make them as loosely coupled as possible, which is a good architecture choice in any case. And that, of course, comes with some further enhancements, like, for instance, having the ability to write each service in its own technology. Now, that sounds scary at first, and keep in mind, that's not the best choice, let's say, from the beginning, because, if you have 20 services, should all 20 services be in their own frameworks and not being maintainable by anyone else? That's not a good idea, but having the possibility to use the best tool for the job on a single occasion is definitely appealing. Now, looking at the front end, well, that's a different story, right? This is usually realized as a monolith. Still, we may have this split between these are our services in the backend, and this is our dedicated front end. Now, a monolithic architecture, of course, has certain advantages. It comes with an out-of-the-box integrated and consistent user experience. At least it's much harder to screw up, let's say, the design and come up with inconsistencies in this monolith. But since it's a monolith, it's developed by one central team, and that comes with larger deployment releases. So you always heard that, oh, yeah, you cannot change now this particular feature in the backend because we only have our next release in a month or so. That can put a lot of stress on a project. And to release that tension, we may look for different architectures. As an example, looking at a tool like, for instance, the Azure portal, you'll see, oh, how are they developing that? After all, these are independent features that are in there. They can even be feature flagged. This thing has quite some velocity. So Azure announces a new service. Well, the UI is already there. How are they doing that? Can only Microsoft come up with such a, let's say, architecture? Do you need a huge engineering team to implement that? Well, if you look around, then more and more companies, even companies that are not in a traditional software business, like here, this German company in the optics sector, they come up with their own solutions. So this is a portal that they created, and this portal features certain functionality that is only accessible to you if you're interested in that kind of product. So this company is set up in kind of different layers. So you can be interested in microscopes and in measuring devices, maybe even in special devices for a semiconductor industry. And depending on what kind of customer you are, you want to have a different set of functionality. Sure, they can be combined. So you could be interested in microscopes and measuring devices. And then the functionality will be combined. But nevertheless, usually you have one of these slices. And if you now go on and say, okay, now who's doing, for instance, the software center here? This software download, we already had some application, let's say written in .NET. How can we now transport that over? Well, if it's technology independent, we could just say, oh, this thing is now a fragment coming from Blazor. And all the rest may still be written in some other language, and it may still just appear on the screen for the end user. So again, the end user doesn't even see that this part is now coming from Blazor. It doesn't have a different UI. It's just in there. It's fluent. It's perfectly consistent. So that should be our aim. So what is this architecture? And you know it already from the title of the talk. It's the microfrontend architecture. Now, idealistically, this architecture looks as follows. Here we have a kind of a flat picture of our microservice backend. It doesn't, of course, necessarily need to be a microservice backend, but just for illustration purposes, we can use that. So if we now place the microfrontend architecture in an idealistic way, then it could look like this. So for each service, and this doesn't need to be a one-to-one relationship, but let's just pretend it is, we have now a corresponding front end. So this is a fully autonomous web application. So it's just serving HTML that can be rendered. Each service still corresponds to the request with an XML, JSON, or whatever response, really focusing on the data. And now the representation for the browser is done by these web servers A to D. So how can they be combined? Yeah, that's a question that doesn't have, let's say, an easy answer. There are multiple ways to implement that. The easiest way here would be to just have hyperlinks. But then the consistency point of view may not be so good. Also, user experience, also kind of a trouble, right? Because frontend A may show a list of users. If you want to see the rows, you click on a link. You got a completely new page. Maybe the layout is completely different, and now you see rows. You don't see the username anymore and anything else, because V is completely autonomous and completely independent of A. Well, there are ways around it using the native web. There are ways like iframes, for instance. And you could use, let's say, some kind of an API gateway, which could be a reverse proxy, for instance, which is now used as a central point for the end user where all these different web servers come together. And so you only would need to specify what is this common layout and where are the fragments from A to D placed in this layout. So that can be rather complicated. As a result, let's propose something slightly different. Let's say, we place it all in the client as one website, so to speak. And this website there is rather dumb, but it still delivers some crucial functionality. It may deliver core and common capabilities, like, for instance, how do you do authentication? It may deliver some shared libraries. Thinking of Blazor already, it could be the well, basic .NET libraries that are already required running anyway for a Blazor application. We could come up with a pattern library. That could be something like Material UI or Bootstrap, you name it. And if we have all that, that's now our website. And this website loads different modules, module A to D. Look at the little symbol here, it's a package. So that's no longer, well, let's say a self-contained application. You don't need to spin up a web server for this. These can be just assets here, can be just your DLLs that are then transporting to the browser. It can be a set of JavaScript and CSS files too. Right. So that's about what we can do and maybe what we should do for microfrontends. There are many options and there are many dedicated talks. Let's look into our options for Blazor. The first option that we have, and that's actually not an exclusive option to Blazor, that's something, well, that we did already in the past using ASP.NET MVC applications, for instance. So it dates back a long time ago. There we could abuse areas. And what we could do is we could place areas in different kind of NuGet libraries, for instance. So each of them would come in the package, be a reflection when the web server starts. It would be read out what we have, and they would be dynamically included, which is quite nice. For a Blazor WebAssembly app, the same thing is true. So we can now write a Blazor WebAssembly app and just reference a set of NuGet libraries, which could be as simple as Blazor component libraries. But they bring all the components, for instance, in lib-A, we have a page and we have something like a menu item. And in library B, we have maybe some dedicated controls, etc., etc. So that's possible, but the reflection part is a little bit difficult in the client, right? Because first of all, we would need to load these DLLs explicitly, so we would need some kind of a discovery service on the backend. And second is if we then have them reflection in the Blazor WebAssembly part, works a little bit differently than on the server side. So regarding paths, etc., that may be a little bit harder to do. It's still possible, but usually what we would do is hardwire that. And so if we do that, we get some advantages. We stay always in the flow. It's all C# all the way. There are no, let's say, boundary breaks. I mean, you develop a component library in Blazor, you already know, oh, it will be used in my my application here. And debugging may be an issue, right? But in general, it's all possible and doable. Nevertheless, the hardwiring and other aspects come with some disadvantages. We would require recompilation, for instance, if we hardwire. So always if there is an update for one of the packages or a new package comes in, okay, we need to get the main application updated. It needs to be shipped, which destroys any caching efforts on the client side. And these caching efforts are crucial for Blazor performance. Also, we mentioned the technology independence as one advantage of microservices. Well, that's not an advantage here because you have just C# everywhere. It's all Blazor. That doesn't look so bright. And we need to evaluate everything before they can start. So in order to know that library A brings a menu item, we would need to load the assembly of library A. But that means we can't have an infinite set of libraries, right? Because, we would need to load all of them at the startup. That's a lot of loading time, and we don't want that. We should actually just know, oh, library A comes with a menu item. Don't load library A, but if the menu item needs to be used, needs to be rendered, then maybe load library A or just a part of library A. Right, so maybe there are other options. This is what I would call, the real microfrontend way. Let's have a look first at this Blazor distributed way. Here is a simple, code base that just adds these libraries via some extension method called add library. If we see that, we just add from our list of assemblies a new assembly that belongs to the type that we just added. And here we have also some menu items. The assembly we use in the Blazor router, so in the additional assemblies, we can say, oh, here you can find more pages. And then in the sidebar, we have a nav menu. This can be standard items, but it also dynamically renders a list of, well, menu item components that we specified in this special singleton class. And again, there is also a mixture possible with existing menu items. Right. So that's always a nice way to, let's say, enhance an existing application. Now, as already mentioned, there is another kind of way, and we will now investigate the options that we have on this way. We can combine it with JavaScript. As a result, we can recombine freely. So really, it can be used together with other frameworks. The common basis is JavaScript, which is anyway the basis of Blazor. And it would also enable lazy loading of Blazor code, because the JavaScript would define what should be lazy loaded, where it comes from. And so when it's needed, the JavaScript code would trigger the loading of the respective assembly. The disadvantage is that this is much more complicated to realize, and it requires, of course, parts being in JavaScript and C#, which, well, has a lot higher barrier for entry. So no, it's definitely not for every developer. Potentially not every developer also needs to use both parts. Maybe the standard dev would only need to use the Blazor or the C# parts. But still, I mean, since both parts are there, at least some developers would need to know how to, let's say, use the system most efficiently. Well, let's have a look at all the challenges that come with that solution, and let's say a demo of a potential mitigation or solution in this area. Challenge 1, routing. What we want to have is that we can combine the routing that comes with Blazor with the routing that comes for, let's say, React or Angular. But Blazor is rather possessive, and so that is very tricky to do. Here we have an example of a Blazor app that has two mount points. One is app for Blazor and one is the React app for React, and both have, of course, their scripts that they render correctly. The React part looks quite easy. It registers two routes, foo and bar, and these then render a very simple text. Now, if we use Blazor as it is by default, then this will not work. But if we say not found doesn't have a layout view, then this may partially work as intended. So let's have a look here. What we should see is that if you have the layout view in here, then we will always get, sorry, there's nothing at this address. Now that's a pity, because it hides actually the content coming, for instance, from React if we go to /foo. If we don't have this, then great. The React view is displayed, and we only have now one disadvantage. Any navigation starting inside Blazor will trigger reload of the application, because there is no single page application routing for routes that are not inherently, let's say, registered. And if we don't have a view here, that's actually what will happen. So kind of a, let's say, problem, because again, the router there comes into our conflict, but we can change that. More on that in a second, and we will see that. Second challenge, and this a little bit more visual demo, is DOM projection. To be efficient, we don't want to have, let's say, several Blazor render trees. We even can't have that because Blazor says, oh, I'm a singleton and I just want to have one entry point, and in there I render, for instance, an app. And so the whole Blazor tree is below this app custom component. Now that's not so nice, especially if you want to say, oh, now I have this Blazor thing and that Blazor thing, and here I have a Blazor thing that should be in the menu, and here I have that Blazor thing that should be a page content, and so on. And that now wants to mix with some other technologies. So we need a way to project out a certain part of Blazor and say, oh, this was our main component. It rendered now in Blazor, but it should now render in a larger page. And here's one way to do it as an example. So don't do that as is at home, but just to illustrate the basic idea. Again, we have a Blazor entry point, and we have this special div with the ID projection target. Then we use a function called project, And this function will actually get something out of projection source and place it in projection target. And Blazor will still, even though it's not part of the actual sub-DOM, it's still part of the Razor DOM, and so that Blazor DOM, so it still works. So here we have a simple counter. It has the projection source. And now if we go into our application, go on the counter page, the counter works. We call this project just to see that, oh, there something changed. It's now below there. We changed where it is in the document object model, but see, the counter is still functional. So Blazor still has, let's say, this attachment. Removing it, it doesn't know that it is now part of a different subDOM, so it doesn't do that. But that's also not let's say, the big problem. You can take care of that. So it should just illustrate this simple behavior here. Right. Dynamic registration. If we want to have microfrontends, we must have a way to say, oh, now dynamically, someone said, I got a component to handle this. But how can we do that in Blazor? I mean, before, and we've seen that everything was like very well predefined. We said, yeah, okay, we have these attributes, and now we have a singleton, and that just populates menu items and so on. So here's a little bit of a more difficult example from the logic. We have this placeholder component, and that will work against this injected iComponent activation service. But what we'll do is we have a button, and each time we click it, something happens. So if we click it the first time, register 2 components dynamically. They are not there before. The components are called first and second. And then, depending on where we are, we either activate or deactivate instances of these components. And as a result, yeah, we will see dynamically that things appear and disappear. The placeholder itself is rather simple. It's more or less just saying I iterate over the currently displayed instances, and then I create such a render fragment and show them. So let's see that. First click registers it. There's nothing to see. But then first component, register that instance. Second component. Now we remove second and bring in the first. And so let's do that. And so we always have now more and more first components coming in with more clicks. So we can instantiate that indefinitely. It just works. Right, so that's dynamic registration. And you can imagine how that, let's say, works in a real application. So you got multiple of these libraries maybe loaded dynamically, and their registration is more or less implicit, no need to do anything. And you can actually refer to components by a certain name because there's no strong coupling between them. Right, shared components. Now, what if other frameworks register components? Like, let's say we have a cool component in React. How can we, let's say, use that in Blazor? Here we're using a Blazor component I called external for this demo, and it has a prop called component name. And via this prop, we can say, oh, take a component now in this example here from React and look up this title or the counter as a name. So what it will do is it places the component in a special div. Then it has a surrounding box and gives them an ID, and then it just invokes a JavaScript function called render react. And it states, oh, here is the name, by the way, of the component I want to look, and here is the render ID, so the part that actually should indicate where to render that into. Right. And so the whole React code is this. We got a functional window called render react. It takes these 2 arguments, looks up the component. Again, here there's no safety net or anything for the demonstration purposes. And then it renders an instance of that component into the container. And here, for instance, we have the counter component. That can be a fully functional React component, like here, and it will just work. So you can now have a counter, as displayed here, inside your Blazor application. And that counter is fully coming from React. You can see that on the ugly button. I mean, I didn't apply any further classes or styling to it. Lazy loading, well, that would be, let's say, a larger demo. Nevertheless, it was solved in Blazor 5, so in the .NET 5 release, and there is no need to now show that. So essentially, it's a challenge being solved, even though, of course, it's still, you need to set up a couple of things. The blog post here has everything noted. By the way, if that goes too fast with the slides, I think there's a video recording, plus I will upload the slides. Just follow me on Twitter. I'll tweet the link soon. So let's bring everything together. How can that look like? A reference implementation. This is a small demo using a frontend framework called Pyral. And what it does is it has a basis in React, but it also comes with Blazor. And here we see the counter just appeared in the menu bar, but the whole application was already there. Now, navigating to the counter shows a page that was completely written in Blazor. So this counter here is a Blazor component. And again, the experience is that this thing is lazy loaded. So when it's needed, so you go to the page, the application is already loaded, and then Blazor loads. And of course, with caching, that's even faster. So it just appears. But so you get the last second or so, even let's say, refined a bit. Because this application is already there, all the parts, and then the rest just flies in. And Blazor is here always lazy loading, which is quite nice. So all the different microfrontends you write in Blazor, they only load on demand, and you define in a little JavaScript code which parts of your Blazor application you want to bring in this web app. Right. So if you're interested in that, that's an open source solution. We could call it a reference implementation. It's called Pyral. It's on GitHub. You can check it out. Again, it has multiple bindings for, I think, 20 or so. I mean, pretty much all of the available frameworks that are there. And you can use it, of course, as Vanilla.js, TypeScript, or whatever you want to. And Blazor is also one of the options that you can bring in very nicely. So what have we seen? We started with a microfrontend architecture in general. We've seen that the idealistic architectures are, well, very open, but they require some work to have something really, let's say, practical. So we then came up with an architecture for distributed Blazor, which can be just used with NuGet libraries. And then we've seen the different challenges and the accumulation of that in a framework for microfrontends, in this case called Pyral. With that being said, thanks for your attention. Any questions, welcome. You can also always reach me on Twitter, of course.
Thank you, Florian. If anyone has any questions, please post them in the YouTube channel. I have one question for you. Why did you create an open source solution to solve this microfrontend problem?
Yeah, it's a good question. So our, let's say, exposure to microfrontends dates back as early as 2016. Back then, it wasn't called microfrontends. And since then, we've implemented, let's say, more or less the same solution, but always, of course, a little bit refined for multiple clients that we have. And after a very successful project in 2018, we realized that, if we implement it one more time, it also won't be better. So let's just make a generic version of what we always, in a very special way, implemented. And that is the result of our open source endeavor in this space. I think so far it's going great. And we are quite happy with the result here.
Yeah. Thank you for contributing to the community, of course, either with talking about microfrontends and, of course, the open source library, which I guess you are part of it, Pyral.
Yeah. Yes.
Okay. So we have no further questions from the audience. I guess it's saying thank you, Florian, for your time. And the next talk is going to be with Alon Felice and Alex Pshul. It will start in 12 o'clock. So you have 15 minutes to go grab some cup of coffee like I did already. And see you in 15 minutes. Bye-bye.